Hello guys, welcome to my channel here. Uh, I'm an HVAC service technician by profession. And I've been doing this since 2016, and I've spent thousands of hours researching HVAC. I started there, but then I developed interest in other subjects, electronics, automation, microcontrollers, programming, that sort of thing. And I've been on a long journey learning about all that stuff, and I figured that I would share my journey. And this will also double as a repository of knowledge for me so that I can go back and refresh on certain subjects. Because once you get so far, you tend to forget the simpler aspects. It seems like, engineers, we always complain about how they design stuff. And I think that it's inevitable at some point that when you reach, a high level of understanding somewhere, you inevitably forget some of the simpler concepts. So this is nice for me to go back and make videos on things like this that I've kind of assumed that I knew everything on, because when you really have to teach something, you don't want to be wrong about it. So I do the utmost that I can to prevent saying something wrong or leaving something out. So uh, I hope you guys can appreciate that. I'm human like everyone else. I make mistakes and blah blah blah. But I do try to, you know, be as thorough and accurate as I can. So yeah, let's get into it here. Um, I wanted to talk about the refrigeration cycle, and I'm probably going to make multiple videos on this. It's been nice to go back and refresh on a lot of this. Um, but yeah, this is the foundation right here for HVAC. Refrigeration. It's all there. And HVAC is a very vast subject. It really is. And but this is a large part of it right here. If you understand this stuff and you understand it well, you're going to be, miles ahead of the other guy. So it's hard to pick a place to start in a cycle. Most people start at the compressor, so I guess I'll do that as well. But what I want to say first as a preface is that every refrigeration system that's compressor driven, that has a condenser and an evaporator coil, they share. This is the operating principle of it all. Okay, so I want to start by saying that there's four components to any refrigeration system like this. You've got the pressure adder, uh, so that's your compressor. Now the compressor has two jobs. A, it circulates refrigerant through the system, and B, it creates a pressure differential. All right, and there's a lot more to that subject. I'll be sure to touch on that a lot because it is pretty interesting. But moving on for now, then we have the condenser, and the condenser can be thought of as the heat rejector. All right, so that is getting rid of heat. Then the third right here is called the expansion valve. Now that's probably the most complex part of this entire thing because there's multiple types. You've got TXVs, they're a mechanical valve. You've got EEVs that use an electronic stepper motor. Then you also have a fixed orifice, which is just a hole. That's all it is. And there's also a cap tube. I forgot to write that one down. But a cap tube is it's just a tube, like a thin tube that creates a pressure drop. That's all it is. Okay. Then we have our evaporator. And the evaporator is the heat absorber. Okay, and knowing those four things, you can probably get an idea already of the idea here. And the idea is to move heat from here and get rid of it here. Move heat from here, get rid of it here. All right, so let's get started with the presentation here. So at the compressor is generating a pressure differential. All right, so the refrigerant here is compressed. Anytime that you compress a gas, you increase its heat. All right, so it's been compressed, so that makes it hot. And there's also more heat added to it, but I'll get to that when we make our way around. So it comes out as a high temperature vapor, and then it enters the condenser coil. First thing, sometimes there's a muffler here. A lot of guys mistake those for filter dryers, but It's really just a muffler to keep the noise down from the compressor. So don't change that with the filter dryer. It wouldn't be good. So anyway, the condenser, the refrigerant flows through it. It begins nice and hot, right? And as it flows through the coil is having air forced through it by a fan, or it can be a water heat exchanger. But we'll just talk about air to air right now. It's simplest to get your head around. So as you're moving air over the coil, it's rejecting heat, and it begins to condense into a liquid. Now, this is a very important concept to understand. Okay, um, refrigerant can exist as a vapor and a liquid. All right, and sometimes they can both be present at the same time. All right, and when liquid and vapor are both present, the mixture is said to be saturated. It's said to be a saturated mixture of refrigerant. And there's an interesting property with saturated refrigerant is that the temperature is stable and predictable based on the pressure that you have in the system at that given time. All right. So if you've ever heard of a PT chart, that's what a PT chart outlines. It shows the pressure and temperature relationship with that particular refrigerant, and it's different for each one. Some refrigerants are better; they have an operating band, I guess you would say. But anyway, as it's moving through this coil, it's condensing into a liquid, and as it does so, it'll remain at a constant temperature. Okay, and eventually, as it's moving through here, it's condensing more and more. It becomes the percentage of liquid keeps rising, and eventually it hits 100%, and the entire line is saturated with, we're filled with liquid. All right, so this is your hot liquid line because it still does carry some heat. All right, and it can be, most of the time, if a system's healthy and operating and charged properly and has good airflow, generally that hot liquid line is going to be, a handful of degrees above the ambient temperature outside. And a lot of that depends on operating conditions as well. But leaves as a hot liquid. Now, it's very critical and important that we have a solid line of liquid here. All right, and I'll get to why that is. And also know that there's usually a filter dryer in this liquid line here to remove moisture from the system if there happens to be moisture in the system, and also to filter the refrigerant and get contaminants out so they don't stop up the expansion valve, because liquid will sweep things up and carry them. So it's very important to have a liquid line filter dryer there. Um, you do see a lot of systems that don't have one, but usually I wouldn't recommend that unless you have a fixed orifice system. All right, so moving to the expansion valve. The expansion valve stops or reduces the pressure of the refrigerant and presents a restriction to the system. All right, so with refrigerant, its temperature is dictated largely by its pressure, right? And if you drop the pressure, have you ever noticed water boils at 212 at sea level, at atmospheric pressure, and so refrigerant and basically all other substances follow the same trend. You can take water at sea level, put it in a literal furnace, and the water itself will not go above 212 until it's all steam. All right, because it's saturated at that point. The same thing happens, and if you ever noticed when you pull a vacuum on something, it causes the water to boil. Well, why is that? The reason why is when you drop the pressure, the liquid itself has a pressure that's inherent to it. And when you drop the atmospheric pressure around it, high pressure goes to low pressure. So the liquid will release its pressure and boil into a vapor. That's my redneck understanding of it. But anyway, when you drop the pressure of this refrigerant, it causes it to boil. And that's why we call this one an evaporator coil. And it moves through here, and it's very cold. Its temperature, if a system's operating properly, is mostly throughout this coil going to be uniform. Okay? And so you have this saturated, cool mixture of refrigerant coming through here, and you have QL. QL represents the warm air that's being blown over the coil from the house. All right. So thermodynamics, heat goes to cold. So the heat from the room that you're pulling over the evaporator will transfer to the refrigerant inside of the evaporator and get carried out of the suction line. All right. So it's gaining heat this entire time, even though it's remaining the same temperature. All right. And it's going to stay that temperature all the way through this coil until it's all a vapor. If it turns into a vapor at this point here, it's going to start to gain temperature from that moment forward. And then it's going to make its way out of the suction line as a superheated, still cold vapor, and the compressor grabs onto it and compresses it and moves it back through. So notice it's still superheated when you get right here. All right, and that's the superheat that remains after the suction line. And also, this refrigerant is being leveraged to keep the windings of the compressor cool. So that compressor is an induction motor, and the windings generate quite a bit of heat, and the refrigerant carries it away and gets rid of it along with the heat from inside the house, from inside the space there. All right. So that's the long and skinny of the refrigeration cycle. There's a lot of nuance here. There really is, and I'm gonna make another video that has a little bit more of the arcane knowledge and stuff that'll really help set you apart from your peers. So stay tuned. Thank you.